Hi everyone. It is week 5 of Introduction to Computers and Information Systems. We're on Unit 3. Unit 3 has lots of details. Okay? And then this week we had a video, we had some group work on word processing. From the video we did a little word processing, a little report on the video. Then in class we talked a little bit about learning. Talked about the email for the skills-based. The issue there was there's supposed to be an attachment. Okay, so we should know how to do that. We also talked a little bit about, proper things to do in an email in terms of being careful not to use it like you're talking with just slang. You just need to be careful. You not only do the work, but you need to understand what you're doing and the value of doing it. The better you understand it, the better and easier it is to actually do the work. You shouldn't focus on just the task. Okay? Details. We talked about bits and bytes again. Okay? So this group of bits represents the ASCII code, and that's a byte. That would be a capital A. Using the ASCII code to represent those bits. So in the computer, this is what a capital A looks like. Why do we need to know that? Bytes we use to measure things like 1 gigabyte. Okay, we measure like volume, like a hard drive, 1 terabyte or what it might be. Bits per second, that's more for like an ISP. You get 15 million bits per second download from Mediacom. So a term we'll talk about later on is bandwidth. We'll talk more about that later. And then down here we give another example of bits processor word size. Machines used to be 32 bits and now they're 64 bits. Why 32 and 64? Why? Oh, it's 2 to some number when we represent that. More on that later. Next thing we did on Wednesday, we went through the outline. We talked about mobile devices, and I didn't list them all, but you have your phones, your tablets, and laptops, netbooks, and so forth. So we have a range of devices that we use that are mobile. We talked about desktops and workstations. And then we talked about servers. Servers can serve things like files to people. You can get apps from servers, and then there's a whole other range of things that happen. Okay? Nowadays, a lot of PCs are used for either servers or they're used here for workstations. Why would you get a workstation when you could get a really good laptop? Well, here you can get a lot more computer for your money. Here you're paying for that portability. Servers can be accessed by mobile devices or accessed by desktops. Built in, it's huge. Okay, there's a lot of devices that have technology built in. Everywhere from your microwave to your automobile to this. There's things all over the world that have built into it. So they're a computer and they're built right into the device. Okay? Automakers are that way. Just all kinds of things in our world today that function, that have inside them somewhere is a processor. Okay, they have memory. It's like, think of your car, a newer car, not my old car. Processor, memory. They might have some kind of storage, or it might be memory and this together. They have in there then, they have operating with that an OS. And operating with that is like an app that makes your car work. Okay? So all kinds of devices with computing built in. Here was Friday, And we're trying to break down a little bit more how this works. Inside the computer, there's an electronic bus. 64-bit would be better than 32-bit. Processors nowadays, if you bought a new computer, most of them I would assume would be 64-bit. You can work with 64 bits at a time. That's better than 32. Kind of go hand in hand here, the bus and that. Inside the processor, these are high-speed storage area, or they sometimes call them staging areas, registered. High speed, the information leaves, if I draw the path, leaves memory, goes into the processor, and then it processes it. What can it do? It can do arithmetic, or it can make a logical decision. It can either add, multiply, divide, subtract, or it can decide if some bits are greater than, less than, or equal. Then based on that decision, it will do something. To move some of the work off from the processor, we have coprocessors. Sometimes they used to have a math coprocessor to do the heavy mathematics works. Graphics cards nowadays, they can be in here attached to the computer. They have a processor. So the work of sending the information to the display can be managed here, so this processor can do other kind of work. Memory. For example, the computers in the lab have 16 gigabytes of memory. That's how much it can hold. What's in there? Well, you have the OSs in there, then you have your app in there, and then you have data in there, and you just start using that up. Now there is something called a swap file or a page file. This is referred to as virtual memory. So you have a piece on the hard drive that acts like, I'll make dots here, like memory. So when the memory can't hold everything, some of that information can be kept here. Just remember, this traveling time is like, I don't know, milliseconds or something, which sounds fast. But this work in here is nanoseconds. Let me draw that in blue again. Nanoseconds, back and forth there. So this is like a turtle, and this is like a jet airplane. So when you have to go to the hard drive, when the computer needs to go to the hard drive to get something, like some data or some program instructions or whatever, it's really slow compared to how fast things are happening in here. And how fast are they happening? Well, they measure it. Everything's by clock cycle, so it takes so many clock cycles to put an instruction in the processor to get processed, so many clock cycles to send it back. That's measured in gigahertz. Billion of cycles per second. Billion. PCs easily run on what 1 or better MIPS. More or less, they can do 1 million instructions per second. 1 million instructions. And what's really cool in here is it can have multiple apps loaded at once, and it can switch between them. Alright, we're going to talk a little more about storage on the next slide. I'll do that first. Storage. Things can be stored magnetic storage, actually magnetic spots. If there's a spot, it's a 1. If there's no spot, it's a 0. Optical, we can burn a little groove in that optical disc. Either there's a burnt mark or there's no burnt marks. Solid state, I'm not really sure how it keeps track of the 1s and 0s, but it's really cool. It can keep track and not be gone when you turn off the computer. Over time, solid state could go away. So this wouldn't be good for permanent storage. It's called flash. But it's very good technology for nowadays in a lot of ways. Okay? In a lot of things we do. Alright. We already talked about high-speed staging areas, arithmetic logic, coprocessor, clock speed, virtual memory. These help determine the computer performance, which we're going to talk about on Monday. One more slide. one more thing we verified. Okay, how big is a K? K is about 1,000. Here's why we say about 1,000. It's really 2 to the 10, so it's 1024. So we use M to represent a million, but it's really a little more than a million. And a billion is G, but it's really more than a billion. We talked a little bit about word processing, spreadsheets, actually producing the actual file when you turn those in so I can look at them. Then we did a brief sharing. We talked about shaming, what lessons was learned there, and the students agreed there was more learned from reading that, and listening to that I should say, than just the fact of being careful what you post. It says something about when people have an opportunity to criticize somebody anonymously, how that can get out of hand. We tied it into the ethics. The assignment was about ethics, and you really got to be careful about determining what you think is ethics. You know, people say everybody has their own. Well, no, there is a set of standards. There's a set of things, because, you know, ISIS thinks they're doing what's right. You know, you can, and they're following their religion, supposedly, not really, but so forth. We did Danny Hillis. We did that. Typed up a little something from that. Dan Pink. We watched that video. And we talked a little bit about Angela Duckworth. We're going to continue over the next couple of weeks, tie this all in with learning. A little bit more each day. And how technology affects that. Oh, we did talk about the trolls. And most people have heard of this. There was a couple students that just never heard that. You don't feed a troll. When a troll puts something out there that's just terrible, what they're looking for are all these other people to say, oh, no, that's bad. Oh, no, that's bad. And you just feed the troll, and then the troll starts growing. Because that's what they want. That's it. That is it. And we have just completed week 5. We got a great start. Won't be long. It'll be spring break.